Namaskar my dear friends. Let us talk about LTSpice simulation. What we'll do is we'll try to simulate boost converter in LTSpice. So as you know, there is very basic circuit for boost converter with discrete components. So as you can see, we have one inductor, we have one switch. So this we will be using a MOSFET, okay, and then we have diode and capacitor, and this is the load. So as you can see, when my switch is open, so this is not the part that will be flowing, so my voltage source will be actually charging the inductor as well as it is supplying to the load as well, okay. And when what will happen is, when this particular switch is getting closed, then the the input voltage will not be going into this path, it will start going into the this path. Understood? So this is how the capacitor will be the only thing which will be supplying to the load at that time, and this is how my voltage output actually reduces. Okay, so my V input will be actually greater than my V output. Sorry, my V output is going to be greater than your V input. Okay, so this will be called as boost converter. Boost converter means once this particular switch is going to get closed, so this particular voltage will be flowing like this, and this is the output which will be driven by this capacitor. So this put together your inductor as well as your capacitor is going to increase the voltage levels. So what we'll do is we'll try to put this particular circuit in the LTSpice, and we'll try to understand what is the values of this particular things. Okay, so let us design one this particular thing. We will have voltage source as 5 volt, which you can see this one, and output voltage we want to make sure that it goes to 15 volt. We will use the designed value for inductor and capacitor will be 150 microhenry and 220 microfarad, and duty cycle we will try to use 0.67. okay, and this is how my switching frequency is made to 25 kilohertz, so that also we will try to put that. So as you can see, the output voltage expression is nothing but, for boost converter we have V output is equal to V input by 1 minus D. So see, D is always less than 1, so it means my output will be always greater than V input. Okay, so this is how you are going to see V output by V input is nothing but 1 by 1 minus D. So that's the expression for your boost converter. So let's open LTSpice. Now what we can do is we can press Ctrl N or go to new schematic. So new schematic is opened. Now quickly we'll put voltage source, then we need one inductor, so I'll put L for inductor, and then we will need one diode. So diode I can put it like this. Then we will be needing one capacitor, and let us say we will put one load resistor, and we will be needing one ground as well. Okay, then we will need one more voltage source for running the switch. Okay, so for that what we will do is we will put one voltage source and plus ground here, and one more MOSFET we need. So we will just try to put one MOSFET which will be acting as a switching component. Okay, now quickly, if we quickly wire this up, to press W. So W will be helping you to wire. Just click and wire. So as you can see, we have almost wired the complete circuit wherever it is needed. This I'll just try to connect it to the pulse source, so I'll just name it as net name, let's say SW node I'll put. Okay, and we have capacitor remaining, so I'll just put it like this. We have this voltage source, so that will be acting as a switching node, so let's say I'll put it as SW. Done. So my complete circuit is done. Now the values of each of them I will try to put it. So I am going to define this as a switching pulse. So what I will do is, let us say I am going to put it as pulse source, and initial voltage will be, let's say, 0, on voltage will be 5, time delay I will just keep it 0, and rise time I'll keep it 1 nanosecond, and fall time also I'll keep it 1 nanosecond. On time, so on time what do you want to give? So the timing that will be given is, we can see that let's say my time period is like a TS or something, then accordingly we will multiply that by duty cycle. So what we can do is we can take a like a variable value. So let's say inside braces we can put D into TS. Okay, so that's the thing, and let's say here I'll put it TS. So I am going to define TS as parametric value, so that like we can change whatever pulse that we want it. Okay, now what else is needed? This I will put it as like a 5 volt. So 5 volt is done. This value was 150 microhenry, that was there in the problem statement. Let us say this capacitor I am going to put 220 microfarad, and let's say this one I will just put 1 ohm. Okay, now we can directly run it and see what is the thing that is happening. The problem is we have not defined the value of duty cycle and the time period. So for that we can give a spice directive. For that I can press dot and it comes a spice directive. So you can put dot param D is equal to, let us say, 0.67, that is 67% I am going to put. Okay, so this one I can put as D. Now again one more dot param I will go, that is your dot I mean dot operator or a spice directive. So dot param, and our aim is to define the time period. So TS will be, since it is 25 kilohertz frequency, so 25 kilohertz will be 1 by f, that will be my time period. So that will be 40 microsecond, or you can put it 0.04 millisecond. Okay, so this is how we have defined both the values, like time period as well as duty cycle both. Now let's run it. So before that we can put configuration time. So configuration time, let's run it for 10 millisecond, because anyway time period is 40 milliseconds, so it is going to be very high time, and then this will be 0. So this is my transient setup. Now let's press run. So this is my run and pause button. Once we press this, we are going to see this is my input voltage, which is 5 volt. Okay, now what is my switching pulse? So you can see switching pulse is this one, right? So switching pulse, if you want you can put it, otherwise if you don't want you can just keep it like input voltage, and then my output voltage will be slowly increasing to the desired voltage, which is 15 volt, right? So that's the thing I want to find out. So you can see my switching voltage output is going to be how much, that we will try to see. So see, you can see output voltage is not coming, or what we will do is, to understand that we'll just press N and we'll write down this as V input and this as V output, so that we can identify which output source, which output like waveform, or which waveform trace is for what purpose. Okay, now before doing that, what we can do is we can try to put exact values of MOSFET and diode, so that it can have a proper switching. Okay, because it is having like this much kilohertz, so that has to be exact MOSFET. So let us pick a MOSFET. So pick a MOSFET of such that we can take, let us say, BZS or something, BSZ. Okay, so BSZ series is like a suitable one, which can be, let's say, 30 volt or 60 volt we can take. So let us say 30 volt is enough, because we don't have much voltage here, so 30 voltage should be enough. Now this diode we can take up MBR series or something, so that also we can take MBR series of, let us say, MBR 30, or like how much, 30 volt or any other voltage if you want, you can take that as well. So MBR on semi is fine. Okay, let's put that, or maybe we will put 100 volt rating, that is better. Okay, so it's up to us like which one we take it. Now if you run, So you can see my output voltage is reaching up to almost like 15 volt or 16 T's, right? So just click that. So you can see my V out is going to almost 15 volt, but there is lot of ripple that is there. So the ripple, as you can see, dy downwards, down bottom corner, you can see dy is around 1.76 volt. So that much is the ripple that is there. So our aim would be to remove this ripple. This is not a very good design, but this is what will happen. Okay, so the amount of ripple that is there, you can see, is around 1.6 volt. Okay, so this is the amount of ripple that is there. So let's zoom to fit, and this is the output. Let us say it is my input voltage was 5 volt, my output voltage is this much, and what is the inductor current if you want? IL1. So just press on this particular component and you will see inductor current. So inductor current was flowing directly and going to almost 40 amperes. So you have to make sure that the current rating of these devices and all those things are, like meeting that criteria. Okay, so good. This was all about boost converter. So boost converter was nothing but the particular scenario was we have to put inductor first, and in buck converter inductor will be next stage. Okay, so alright guys, thank you.